Hi, welcome to my video on radians, part 5. Find the reference angle given the radian. Find the reference angle of each radian for exact values of trig ratios. I'm going to use two methods. I'll go through method 1 and then I'll go through method 2. Method 1 is change to a degree. So we have two ways to change the degree. We can say pi is 180 degrees, and we can simplify that. 3 and 180 is 60. 60 times 2 is 180. Or we can multiply by 180 over pi is another way to change it. So it's your choice. 180 over pi. The pi's cancel out. 3 into 180 is 60, and we get 120. And when we do that, we plot 120 degrees on the circle. So 120 degrees that's a 90 and so much more. So that's 120. Then we draw a terminal arm and 120. So this is 180. Subtract 120. So this gives us 60. So our reference angle is 60 when we produce the right triangle. And I'm going to do it again. So this time I'm going to do it faster. Pi is 180 degrees divided by 6. 6 and 180 goes 30. So I get 150 degrees. So if you want to find a reference angle for 150, again, you start at right here and you rotate 90. 150 goes up right here, and because I have 150, then we draw the terminal arm. Then the reference angle is right here, so that's 150. This arc right here is 180 minus 150, so this arc right here is 30. So that means the central angle is 30. So we have a reference angle of 30. And right here, our reference angle is 60. And we got a negative 7 pi over 4. We're changing negative 7, change pi to 180 degrees, and divide by 4. 4 and 180 goes 45. So that makes it a negative 315 degrees. And we want the reference angle. So here's the circle. So 315 degrees negative, we got to go this way. 90, 180, 270, and right to here. So that's a negative 315 degree rotation. That means that this arc, little piece of arc right here is 360 minus 315, so that's a 45. So that means when you draw your terminal arm, that makes this angle in here 45. When you drop your perpendicular to the x-axis, just drop perpendicular to the x-axis here, and so your reference angle is 45 degrees. So that's one way to do it, but I got a little faster way when you're given the radian in terms of pi. So notice method 2, pi over the denominator is your reference angle. So if I just split this like this, notice I got 2, and that's 180 divided by 3. 180 divided by 3 is 60. Reference angle is 60. Every time. Again, if you pi over 6. So that's 5. Pi over 6 is 180 divided by 6. So that's a 30. So guess what? Your reference angle is 30. So the pi over 6, it's the pi over the denominator that gives you your reference angle. And right here, we got pi over 4. So that's pi over 4 is 180 divided by 4. So 180 divided by 4 is 45. And your reference angle for this rotation is 45 degrees. Notice it's just notice 3 and 180 is 60. 3 times 60, 180. 6 and 180 is 30. 30 times 6 is 180. 4 and 180 is 45. 45 times 4 is 180. So you got a 3 in your denominator, you get a 6. You got a 6 in your denominator, you get a 3. If you got a 4 in your denominator, you get a 45. That's a fast way to get your reference angle. And then when you plot it, you can plot, you know, if you wanted to, take 2 times 60, make 120. So when you draw your rotation of 120, you know your reference angle is 60. When you draw your rotation here of 150, you know your reference angle is going to be 30. So there's your 150 rotation, reference angle of 30. And when you draw your negative rotation right to here, you know when you stop that your reference angle is going to be 45. And this is a fast way to do it. And I've learned that little trick. Find the reference angle of each radian given the rep angle. So the fast way, the 7 times pi over 6. Pi over 6 is 180 over 6. So your reference angle is 30. And what's your rotation? 7 times 30, 210. Because if that's a 30, 7 times 30, your reference angle is 180 divided by 4, which is 45. So your rotation is 3 times 45, which is 135. And we have pi over 3, which is 180 over 3. So your reference angle is 60. So we have pi over 3, which is a 60. So we have a negative 5 times 60. So your rotation is a negative 300 degrees. I said 330. 300, negative 300. And we have pi over 6. That's 100 again. We do that. Pi over 6, that's 180 divided by 6, so the reference angle is 30. So we have a negative 11 times pi over 6, which is 30. So you get a negative 330 degrees. Again, this is the fastest. No, you can't go wrong. Pi over 6, 6 into 180, 30 reference angle. So when you plot the 110 rotation, you know you're going to get a 30 reference angle. And just to do that very quickly, 210, 90, 180, and some more. And draw your terminal arm. So your reference angle in this triangle, the reference angle is going to be a 30. It's a 210 subtract 180 gives you this arc is 30. But this is a fast way to do it. And again with this one, we got 135 rotation. So that's a 90 plus some more. There we are. Draw your terminal arm. And the reference angle is 45. So when you stop here, you know this reference angle is 45. That, again, this arc right here is 45 because that's 135. And 45 makes 180 perpendicular to the x-axis. We know we're going to have a 45 reference angle. And with this one, we got a negative 300. So negative goes, there's a circle. So negative 300 starts here. 90, 180, 270. So we're right here. There's the terminal arm. So our reference angle is going to be a 60. There's a 60 degree when we drop the perpendicular to the x-axis. Remember, that's a negative 300. Then this right here is a 60. Notice I don't have it drawn proportionally. But the reference angle is going to be a 60 in that when you wherever you stop. And in this one, we've got a circle. We got a negative 330. So all the way around like that. 270 right on over to here. And that's a negative 330. But we know we're going to have a reference angle of 30. So when you draw your terminal arm, that's going to be a 30 right there. And again, that's 330. This arc is 30. perpendicular to the x-axis. This angle, central angle in here is 30, which is your reference angle. And that brings us to a fast way. And then pi over your denominator is your reference angle. And you know in the quadrant what your reference angle is going to be when you do your rotation. If you like that way of finding your reference angle, click on the like button, subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.